Welcome to this video lecture session. So in this lecture session, we are going to discuss about the concept called parsing. In natural language processing, so why we are going for parsing concept and what is meant by parsing and how we can use the parsing technique to find the solution. This is what we are going to discuss in this particular session. The session objective is to understand the classical parsing and the types. We are going to specifically discuss about top-down parsing and bottom-up parsing, and then we are going to see one specific algorithm, that is CYK algorithm, and finally we are going to see one example so that we will understand the concept of CYK algorithm in a better way. Okay, so these are all the session objectives for this particular session. So first we are going to see what is meant by parsing, and then we are going to see the types of parsing, top-down approach as well as bottom-up approach, and then we are going to see one membership algorithm, that is CYK algorithm, and after that we are going to see one example to understand the concept of CYK algorithm. This is our session objective. So first of all, what is meant by parsing? So parsing is nothing but a method of analyzing a sentence to determine its structure according to the given grammar or according to the grammar to get the meaning out from the sentence. The main intention of to go for parsing is to get out the meaning from the sentence by proper way of analyzing from the given grammar. This is the meaning of parsing. We will see. Parsing is the process of finding the derivation. So that is, it will start from the start symbol and the tree will end in the terminal node. So this is the formal way of explaining parsing. Okay. It mainly shows how a particular sentence could be generated by the rules of grammar. So we already discussed in the previous session. So what is context-free grammar? So what are all the components involved in the grammar? And in every language, okay, so this grammar plays a major role. This is also we have discussed. Okay. Now with the help of grammar, okay, to get the meaning out of the sentence, we are using the concept called parsing. Okay. So if suppose the sentence is structurally ambiguous, for example, for one particular sentence, there may be multiple ways of deriving the parsing tree. So this will lead to structural ambiguous. Okay, so in that case, there might be more than one possible derivation can be occurred. So this is this is also possible. Okay, so in that case, which one we can choose? So that we will see later. So that case we used to go for probabilistic context-free grammar, PCFG. Using the concept, we will choose which tree, which possible derivation might occur probably, more probable. Okay. So this is all. So in the parsing concept, so this case is also possible. That's what we are trying to convey here. Okay. So parsing algorithms give a strategy for finding a derivation by making choices among the derivation rules and deciding when the derivation is complete or not. So this is the main concept of going for parsing algorithms. So once again I will repeat. So what is meant by parsing? So it is a method of analyzing a sentence to determine its structure according to the given grammar, and main intention is to get out the meaning from the particular sentence. That is what it means by parsing. Okay. So now there are two major types or categories of parsing. One is top-down parsing and next one is bottom-up parsing. Okay. So top-down parsing is also called as hypothesis-driven or goal-driven. We used to call like that. Okay. So it looks at goal first and then it will see which rules can be applied. So this type of parsing, it will start looks at the goal first and then it will see which rules can be applied. So we already discussed context free grammar, the set of rules, production rules, right? So start symbol tends to some non-terminal variables and also start the various phrases. It will lead to various categories. So we already know that one context free grammar is a set of four major components. Yes. Okay. So okay. So this is what we already discussed. Okay. Now when you come for top down parsing algorithm, so it will look in the context of goal and it will see how the rules can be applied in an effective way to reach that particular terminal node. So this is what the concept of top down parsing. Okay. So these are all some example grammars, okay, for our understanding purpose. So we already discussed in detail about context free grammar and all the rules. Okay, so when we talk about grammar, so it consists of, the rule consists of left hand side as well as right hand side. So left hand side, if you see, only one symbol will be there. Right hand side, more than one symbol will be there, and there are certain strategy is there to form the grammar. Okay, so starting symbol, the S represents the starting symbol. So it tends to, or it derives to noun phrase and verb phrase. So it can be further extended. The parsing tree can be further extended using these kind of rules. Or noun phrase, it will tends to pronoun. Noun phrase, it tends to proper nouns. Likewise, it will derive until it reach the destination or terminal node. So these are all some examples. Okay. So the sentence, example sentence is given, the flight grammar from the text. Okay. So in that case, so if you see here, so determiner. Okay. So these are all case, it will comes under determiner, and these are all case, book, flight, meal, money, all these things comes under noun. And also if you see here book, the word book comes in both noun and verb. Okay. So in that case, sometimes it might be possible for a structural ambiguity. Okay. So in such situations, okay, okay, there might be possible of deriving more than one parsing tree. So in that case, how to decide which parsing tree we can utilize for that particular context of sentence. Okay, so in that case, PCFG plays a major role. So we will discuss later the concept of probabilistic context free grammar. Okay, so and also these are all few examples to understand that what, how it belongs to that particular category. Okay. So these are all few example derivations. So how parsing tree can be done in the top-down approach. Okay. So for example, the sentence is given, book that flight. Okay. So whenever we talk about top-down approach, it will start from the start symbol. Okay. So it will look at the goal first. From that, it will penetrate using the set of rules given in the grammar. Okay. So this is what given. So first, I am starting from the start symbol. Okay. Then I am checking for the set of rules in the grammar. Okay. If you see here, there are three set of rules for a starting symbol. Starting symbol derives to noun phrase and verb phrase, or starting symbol can be derived to auxiliary, noun phrase and verb phrase, or starting symbol can be derived to or tends to verb phrase. So three possibilities are there given in the set of rules. Okay, are given in the grammar. Okay, this is common. Okay, so now I am applying here. Okay, so first starting symbol can be tends to noun phrase and verb phrase, or starting symbol can derive to auxiliary, noun phrase, verb phrase, or starting symbol can be derived to verb phrase. So based on the three set of rules given for the starting symbol in the grammar, so I have drawn the parsing tree, the first step in top-down approach. Okay. Then after that, each non-terminal, these are all non-terminals, we very well know. So each non-terminal, again further we can derive using the given set of rules. Okay, so until how long we can do? Until the tree or the leaf branch, okay, it reaches the terminal node. So until the branch reaches the terminal word or terminal node, okay, so we will further extend the trees, okay, or further extend the branches by using the set of rules. Okay, so here we are using two terms. Okay, majorly we are using two terms. One is non-terminal, next one is terminal. So non-terminal is nothing but we can further divide or derive into several terminal or non-terminal words. That is the meaning of non-terminal. Terminal means the individual word. We cannot further derive it. Okay, so that is the meaning of these two terms. Okay, don't get confused. Okay, so once again I will repeat. Okay, so we are looking on the concept of top-down parsing. Okay, so top-down parsing, it is a hypothesis-driven approach. That means it will start from the start symbol and it will move towards the terminal node using the set of rules given in the grammar. Okay, this is one of the examples we have discussed for top-down approach. The sentence given is book that flight. Okay, so first I am taking starting from the start symbol. Next I am checking the grammar. So what are all the possible derivations available for the starting symbol? Okay, so if you see here grammar, there are three various possibilities are available for the starting symbol to derive further. Okay, so I am checking the three possibles. Okay, so I am drawing the parsing tree for three possible conditions. Okay, then from that, if you see here, noun phrase I am taking. Okay, so noun phrase, so it can be again further derived into determinant and nominal, or noun phrase can be again further derived into pronoun. Noun phrase again further derive into proper noun. So based on that, again I am going for further categorization. Okay, if you see here, noun phrase is further derived into determiner and nominal. Or otherwise, noun phrase can be further extend or derive into proper noun. Or noun phrase again further derive into determinal and nominal. Or noun phrase proper noun. So based on the set of rules, okay, so we will further extend the parsing tree until it reach the terminal word. Okay, so what is the use of parsing? So it is a method of analyzing a sentence to determine its structure based on the or according to the given grammar. Okay, so to get, this is what important, to get the meaning out from the particular sentence. Okay, in what context the sentence is given in order to get the appropriate or accurate meaning. So the system will use these parse trees to get out of the or to extract the meaning from that particular sentence. Okay, so when the structural ambiguity occurs, okay, there might be a chance, there might be a possibility for more than one derivations or more than one parsing trees can be framed in that particular scenario. Okay, so there are several concepts are there like PCFG to choose out of this number of parsing trees which one I can choose for that particular context. Okay, so in that case we can go for using PCFG concept. Okay, so next one, so first we have discussed about the top-down parser. Okay, so it is a hypothesis-driven approach. Next, we are going to discuss about the bottom-up parser. Okay, So bottom-up parser is the data-driven approach. So it will start from the individual word and it will move towards the start symbol. It will go in the reverse direction. So it will start from the terminal node and it will move towards the parent node or start symbol, and it will check whether the solution is obtained or not. Okay. So this is what explained here. Okay. We will see one example so that you will understand better. Okay. The same example I am taking. So book that flight. Okay. So in top-down approach, how it will start? So it will start from the start symbol. Then it will check the set of rules in the given grammar, how further the tree can be extended until it reaches the terminal word. Okay, so this is what the top-down approach. When we go for bottom-up approach, okay, so we will start from the individual word. So first write all the individual words. Then we go for the previous step. Okay, in the reverse order we are going. So sometimes we used to call it as reverse engineering approach, right? So likewise, so we will start from the terminal node and then we are moving further to reach that particular destination. That is the starting symbol. Okay, so how to reach that one? So first step, we will check the each individual word, what category it belongs to. Whether it belongs to the category of noun, or whether it belongs to the category of verb, or whether it belongs to the category of determiner. Okay, so first we will check using the set of rules given in the grammar. Okay, so we already know. Okay, so noun, verb, okay, so book, flight, all these things will come under the category of noun. But if you see book, the word book also comes under the category of verb. Okay, so there might be chances for two different types of structures. Okay, so first I am taking here. Okay, so book I am writing, it belongs to the category of noun. Similarly, that this belongs to determiner. Okay, so I am mentioning that one. And flight belongs to noun. Okay, this is one possible way of approach. And what is another possible way of approach? Book belongs to the category of verb. Okay, so similarly, I am writing the previous non-terminal phrases from where these particular words are derived. I am going to the previous step. Okay, so book belongs to the category of noun, that belongs to the category of determiner, flight belongs to category of noun. So I am going to the previous step from where it derived. Okay, so now from there, okay, so again I am checking the grammar. So I am checking that from where this noun phrase is derived. What are all the possibilities? So again it will go to the non-terminal side. Okay, so from which kind of non-terminal this particular phrases are derived. So based on the grammar, again I will go one step previous. Okay, so I will check based on the rule, I will go further. So here bottom up approach, how we will start? We will start with the terminal word, and the next step we will check which non-terminal word that derives this particular terminal word from the given grammar, and then we will extend it further in the same process. Okay, then previous step, which non-terminal can derive this non-terminal and terminal. Likewise, we will go step by step further until it reaches the start symbol. Okay, so if you see this particular category, okay, so only the rightmost tree can continue the derivation here. Okay, that means, okay, so this possible case can be able to go further. Okay, so from that we can able to find out, so this is the possible way. Okay, so it will belongs to the verb phrase. In that case, the book belongs to the category of verb in this particular approach. Okay, that means in this particular context. Okay, so this is how we can able to get the meaning out of the sentence with the grammar. That is the meaning of parsing. Okay. So what is mean by parsing? Once again I will repeat. So it is a method of analyzing a structure. So to determine its, it is a method of analyzing a sentence to determine its structure according to the given grammar. The main intention is to find the meaning out of that from the particular sentence. So this is the meaning of the parsing. And we have discussed about two different basic concepts of parsing. One is top-down parsing and next one is bottom-up parsing. Okay. So top-down parsing, it is a hypothesis-driven approach or goal-driven approach. Bottom-up parsing is a data-driven approach. So it will start from the terminal word and it will move towards the previous step until it reaches the starting symbol. So there are several challenges while we are using these two major parsing techniques. So while we are going for top-down approaches, sometimes okay, we also feel that it is not consistent with any of the words. That is also possible in case of top-down approach. Okay, while we going for bottom-up approach, sometimes we are getting the derived trees, so sometimes it will not make global meaning. Okay, so this kind of situation also possible in case of bottom-up approach. Okay, so majorly, okay, so this is the major way, major problem parsing technique will face structural ambiguity. Okay, so in that case, there may be chance of more than one or two possible derivation. Okay, these are all few challenges when we are using the parsing techniques, whether top-down approach or bottom-up approach. So now we are going to discuss one algorithm, that is CYK algorithm. Okay. So what is CYK algorithm? Three individual persons, they develop an algorithm to answer that particular question. So whether the particular given sentence belongs to the grammar or not. So in order to identify, so three individuals, they have developed one algorithm. So one is Koch, Younger and Kasami. So they have developed an algorithm to find out the solution for this particular step. So that algorithm we are calling it as CYK algorithm. So the basic concepts of CYK algorithm is, so the structure of the rules in the CYK algorithm follows Chomsky normal form. In short, we are calling it as CNF form. Okay, this is one of the main condition. Okay, the CYK algorithm use the condition that, so it follows Chomsky normal form. We will see what is Chomsky normal form, and also it uses dynamic programming or table filling algorithm. Okay, so this is the basic concept of CYK concept algorithm. Okay, now we will see what is Chomsky normal form. Okay, so we have discussed, we are going to discuss about CYK algorithm. Okay, CYK algorithm is also called as membership algorithm. That means it is used to check whether the given sentence belongs to the particular grammar or not. Okay, so it belongs to bottom up approach. Okay, another one important term, concept, it belongs to bottom up approach. What is meant by bottom up approach? It starts from the individual word and it will go further, taking to the previous steps until it reaches the start symbol. Okay. Now the CYK algorithm will work if the given set of rules are in the Chomsky normal form or CNF form. Now we will see what is the major conditions in CNF form, okay, or Chomsky normal form. Okay, so normal form is described by a set of conditions that each rule in the given must satisfy. Okay, and the important thing is, Okay, so the context-free grammar is in Chomsky normal form if each rule has one of the following forms. Okay, normally when we talk about grammar, it consists of left-hand side and right-hand side. Okay, so for example, left-hand side, it will belongs to some noun phrase and verb phrase. Okay, so left hand side, if you take, it consists of single symbol. Right hand side, it consists of more than one non-terminal words in the case of context-free grammar. Okay, there are few challenges we are facing while we are using the context-free grammar approaches. So that's why these three peoples, they have developed or extended the simple approach, that is Chomsky normal form. Here, the condition is, okay, this is the left hand side, this is the right hand side. Okay, so left hand side, so the rule consists of at most two symbols on right side. Okay, so majorly it will contain only two symbols on the right side, that is two non-terminal words on the right side. Okay, this is belongs to Chomsky normal form. Otherwise, we can say this set of rules does not belong to Chomsky normal form. Okay, what is the first condition? So in the right hand side of the rule, it must contain maximum of two non-terminal words. Okay, that can be split further. Okay, or otherwise it consists of only one terminal word. Okay, so here in this example, okay, small letter are used to mention terminal word or terminal symbol. Capital letters are used to mention non-terminal words. That means we can further derive it, that particular non-terminal case. Okay, or it belongs to null string. Okay, so this is the major condition in Chomsky normal form. So what are all the major conditions? The right side of the rule will contain maximum of two non-terminal words. It cannot be more than two. Okay, so if the set of rule contains more than two, we can say it is not in CNF form. Or it contains only one terminal symbol. Right hand side, if you check, it contains only one terminal word, the final word. Okay, it cannot be further extended or it cannot be further derived. Okay, that is the terminal word. Okay, these are all technical terms used in this particular concept. Okay, terminal word or terminal symbol means it cannot be further derived. Okay, non-terminal words or non-terminal symbols can be further derived. Okay, using the set of rules. Simply we cannot derive. Using the set of rules in the given grammar, we can further derive it. Okay, so once again I will repeat. So Chomsky normal form, the condition is right side of the given rule, it must contain maximum of two non-terminal words or it must contain single terminal word. Then only we can say the particular set of rules belongs to Chomsky normal form. Okay, so how we can use or how we can follow CYK algorithm to find whether the given sentence belongs to the grammar or not. Okay, so the basic concept is, so we will construct one triangular table. Okay, so how we can do? So here each row corresponds to one length of the substring. Okay, so we will see one example so that you will understand better. I will quickly go through it. Okay, so based on the length of the string. Okay, for example, book that flight. Okay, so in that case, what is the length? So how many words are there? Here three words are there. So we are going to build the triangular table of 3 cross 3. Okay, so here the given string has the length of 5. Okay, that's why they have designed, okay, 5 cross 5 tabular column. Okay, or triangular table. Okay, so this is the first step we will do in the CYK algorithm, and then we will derive one by one, step by step. Okay, so So CYK algorithm, as I already told, so it is also called as membership algorithm. Okay. So it is used to find whether the given string of words belongs to the particular grammar or not. Okay. So as I already told, context-free grammar consists of four major components. What are all they? One is starting symbol. Next one is production rule or set of rules. Next one is V belongs to the terminal, and okay, sorry, V belongs to the non-terminal, and epsilon belongs to the terminal. So grammar belongs to four things. Okay, we can say non-terminal, terminal, production rule, and start symbol. Okay, so it consists of these four main components. Okay, so what are all they? Non-terminal symbols, terminal symbols, production rules or set of rules, and starting symbol. So if any component is missing, we cannot say it not belongs to that particular category. Okay. So whenever we come for probabilistic concept, okay, one more term will come, that is a probability. So how much probability each word belongs to, that is also included in this particular case. But the four major components of grammar is non-terminal symbol, terminal symbol, production rules, and starting symbol. That is what mentioned here. Okay. What you have to find, whether the given string is in the language or grammar. So this is what we are going to find it out. So W normally used to represent the given string of words, okay, or sentence, and string of sentence. Okay, this is what we are going to find out using the COK algorithm approach. Okay, so now we will see one problem so that you will understand better. Okay. So what is the concept of COK algorithm? Once again I repeat. Okay, so it is you first it will check whether the given grammar is in Chomsky normal form. What is Chomsky normal form? Major condition, the right hand side of the set of rule, it will contain maximum of two non-terminal words. Okay, or otherwise it contains a single terminal word. Okay, if it is in that particular way, okay, so we will say it is in Chomsky normal form. Okay, and once it is in Chomsky normal form, next step we will construct the triangular tabular column based on the given length of the given input string, and after that we will see further derive and we will find it out whether that particular sentence belongs to the grammar or not. Okay, now we will see one problem so that you will understand better. Okay, for that I am just switch off the projector. 1 minute. Okay. So now we will see one problem to understand the concept of CYK algorithm, how it works. Okay. So we are taking the input string. Okay. So input string is given by the word W. So AABB. Okay. So understand that, okay, for our understanding purpose, the small letters will say that it is a terminal word. Okay, so capital letters will say that it is a non-terminal word. So what is terminal word? It cannot be further derived, or it is a individual word. Okay, terminal word, okay, so it can further derive. For example, that flight. Okay, that can be further derived into that and flight. Okay, so this we are calling it as non-terminal word. So this we are calling it as terminal word. This will not be further derived, but this can be derived into that and flight. Okay, so this is the meaning. Okay, so just for understanding purpose, I am mentioning here. Okay. So this is the problem given. One sentence is given A, B. Okay. So for example, okay. So what is the length of this particular string? 4. Okay. So A, B. Okay. So length of the string is 4. Okay. Now what we have to do? We have to construct 4 cross 4 triangular matrix. Okay. So that is the first step. Okay. And also in this problem, the grammar is given. Okay. So S tends to AB and S tends to BB. A tends to CC, AB and tends to A. Similarly, B tends to BB, CA and then B. Okay. Similarly, C tends to, okay, so BA and AA and B. Okay. So this is the grammar given in this particular problem. So see here, left side there is only one symbol. Okay. So first I am checking whether this belongs to Chomsky normal form or not. If it is in Chomsky normal form only, we can able to use this COIK algorithm. Okay. So what is Chomsky normal form? Right hand side, it consists of maximum of 2 non-terminal words or single terminal word. I am checking here. So starting symbol, there are 2 cases. Okay. Starting symbol S tends to AB and S tends to BB. Okay. So it can be written as S tends to AB, S tends to BB. So in short form, I have written like this. Okay. So here if you check right hand side, only 2 non-terminal words are there. Okay. So it belongs to Chomsky normal form. I am checking all the cases. It consists of maximum 2 non-terminal words. Okay. See here, but it also consists of 1 terminal word. Okay. So it is perfectly in CNF form. Okay. So no problem here. I can able to apply COIK algorithm. So okay. What is the length? It is 4. So I have to draw 4 cross 4 triangular column. Okay. Okay. See here, x-axis 1, 2, 3, 4, I. Similarly, y-axis also 1, 2, 3, 4. So first step, I have drawn the 4 cross 4 triangular matrix or triangular table. Okay. What next I am going to do? So COIK algorithm is a bottom up approach. Okay. So I am starting from the individual word. Okay. So I am writing here in each cell or matrix, I am writing the individual word. Okay. Now, what about the first step? First step, I have to fill the bottom rows. Okay. So it is a single derivation. So we have already discussed in bottom up parsing, right? So first each word it will take and it will check from which category it derived from. Okay. So it is a single step derivation. Okay. While going for second step, it is a, see here, 4 cells are changed to 3 cells. Okay. Or otherwise from 3 cells it again derived to 4 cells. Okay. So how it will come from 4 to 3? Okay. So once again I will explain for our understanding. Okay. So I have written all individual words here. That is the first step. Okay. So first step here, when you check about the first row, okay, so it is a single derivative, okay, of non-terminal words. From which non-terminal these words are derived? Single one. Okay, single order derivative we can say. Okay. If you check the structure of the tabular column, these four cells are again mapped to three cells. Okay, so how it occurred? So while comes for the second step, okay, so this is the first step, it is a single derivation. Second step, if you check, so I am taking these two combined and I will map here. Okay, so this you see carefully, these first two cells I am combining and map here. Similarly, second two cells I am combining and mapping here. Similarly, third and fourth I am combining, I am mapping here. Okay, so this is how the four cells are mapped to three cells. Okay, then how these three cells are mapped to two cells? Okay, so I hope you understand how this four becomes three, and now how this becomes two. Okay, so first three cells are combined and it will map to this particular cell. Similarly, second, third, four cells are combined and it will map here. Okay, this is how it will follow the steps. Okay, so finally for the last one, all the cells are combined. Okay, now we will see step by step so that you will understand better. Okay, now first case, first step, it is a single derivative, right? Now I am coming back to the grammar. I am taking the first cell. It is a terminal word A. So I am checking in the given grammar. So from which non-terminal it is derived. Okay, see here, A is a non-terminal word that tends to A. Okay, so I am writing here A. Second one, again A. I am checking here, any other possibilities? No. So A that tends to non-terminal word A. I am filling here. Similarly, I am checking for B. Okay. So while checking for B, there are two possibilities. One is B tends to B. Next one is C tends to B. Two possibilities. Okay. So I am writing here B comma C. Similarly, last one also B. I am writing here B comma C. Okay. So once again I will repeat. So first step, it is a single derivative. Okay. So I am checking here set of rules from where the terminal word A is derived. Okay. So I am checking the condition. That is only one possible condition. This A tends to A. So I am filling in that particular position for A. Okay. For B, there are two possible cases. One is B tends to B and C tends to B. So I am filling there B comma C. Now I am going for the next step, previous step. Okay. Here how we have to do? It is a combination of two cells. First two cells, it is a combination of here. Okay. So what is first two cells when you combine? It is A and A. Okay. So now I am checking here. What is the possible conditions for getting the value AA together? Okay. So AA together. So this is what I am checking here. Okay. So while I am checking, okay, so there is only one possible condition. Okay, so AA. Okay, so I am combining these two cells. Okay, what is the non-terminal word? AA. Okay, I am checking for the combination in the set of rules where AA comes. I am checking in the first one, no. Second one, no. Third one, no. Fourth one, C tends to AA. Okay, so I am writing here C. Okay, next, for this cell, so it will map from these two. Okay. So when you map these two cells will map and give here. Okay. So what is the word? A and B comma C. Okay. So now I am combining these two. So one is AB, next one is AC. Okay. Now I am checking here AB where it comes. So AB S also tends to AB, A also tends to AB. So I am writing here S comma A. Okay, similarly I am checking for AC. So AC there is no possibility. CA is there but AC is not there. So here out of these things S comma A. So I am writing here S comma A. Similarly, what about for this cell? So it is mapped by these two cells. So B comma C and B comma C. Okay. So B comma C and B comma C, I am multiplying it. So it becomes BB. So B into B, B into C, then C into B, then CC. So now I am checking the set of rules. Okay, what about BB? So S tends to BB and also B tends to BB. So S comma B. Okay. So what about B? Yeah, nothing is there. Then BC. BC, there is no case. Okay. It will discard it. Okay. What about CB? CB, there is no case. It is discarded. What about CC? CC, yeah, A is there. Okay. So here, three non-terminal words are there. I am writing here S comma A comma B. Okay. So from that it is derived. Okay. Now two steps completed. Okay. So once again I repeat. So first step we are checking each individual case the non-terminal words. Okay. From the given set of rules. Second step, for this filling this particular triangle cells or matrix, we have to combine these two and it will come here. These two will be combined and it will come here. These two will be combined and it will come here. Okay. So I have filled that one. Okay. Now I am going to the next step. So what is the next cell? Only two cells are there. Okay. From four cells, how two cells come? Okay. So now I am going to map these three. These three I am going to fill it here. Similarly, I am going to map these three cells and I am going to fill here. Okay. This is what I am going to do now. Okay. Understood? Okay. Four cells are there, but now I am going to do for two. Okay. So how four becomes two? We are going in the reverse order because we are using bottom up approach, right? Okay. So I am going to combine these three and I am going to keep it in the first one. Similarly, I am going to combine these three cells and I am going to put it in the second one. Okay. So what is the first three cells? A, B. Okay. So I am writing for various combinations. So when we can write A, B, otherwise we can write A, B. Okay. So there are two different combinations. One is A, B. Next one is A, B. So first I am combining these three cells. Okay, A, B. I am combining A, B. There are two combinations. So what about A? This one. A. A belongs to this one. What about AB? So while I am combining these two cells, where I have written, it will be written here. So it is S comma A. Okay, understood this one? So okay, yeah. Once again I repeat. Okay, so I am combining these three cells. Okay, so I am writing for different combinations A and AB or otherwise AA and B. Okay, so when I take the individual A, okay, so it belongs to the non-terminal A. I am writing here. When I am connecting the next two cells AB, okay, so AB, while we merged these two cells, it is mapped to this one. So I am writing this non-terminal here. Now I am multiplying. So it gives AA and S, AS, AS. Okay. Now I am checking. Okay, from the given set of rules. Okay, so AA and AS. So AA, C it is there. Okay, so I am writing here C. Okay, for AA, C is there. AS, there is no combination, so leave it. Okay, similarly, next, AA. Okay, so these, when these two cells are combined, it comes here, C. Okay, B. So when B is there, it is B comma C. Okay, so I am again multiplying this one. This becomes CB and CC. Okay, now I am checking the set of rules. What is CB? CB is there, it is not available. So it is ruled out or it is discarded. What about next one? CC? Yeah, it is available. A tends to CC. So I am writing here A. Okay. Similarly, C comma A. Okay, so I am writing here the value is C comma A. Okay, the value is C comma A or A comma C. We can write in the order A comma C. Okay, so this one is finding out. So similarly, what about this cell? So these three cells are combined. So I am writing here. So these three cells are combined and it will come here. Okay, I am writing here so that you will understand better. A, B, B. Okay, so there are possibilities. This is one possibility and another possibility is A, B and B. Okay, so these three cells. So first one, A tends to A. I am writing here. Okay, so when these two cells are combined, it will merge here. So that is S comma A comma B, the value. Similarly, when you combine these two cells, it comes here S comma A, and what is the value for B? It is B and C, B comma C. Okay, now I am multiplying all these things, AS, AA, AB. Okay, similarly here SB, SC, AB and AC. Okay, now I am checking the set of rules. What are all the non-terminal words are possible? AS is possible, first one, no. So we can leave it. It can be discarded. Okay, so what about AA? AA, yeah, C. It is possible, C. Similarly, what about AB? AB, two cases. S tends to AB, A tends to AB. So I am writing here S tends to AB, A tends to AB. Okay, similarly, SB I am checking. Next combination SB I am checking. It is not possible, so you leave it. Okay, into represents, I am leaving that one because in the given set of rules that combination is not possible. Okay, SC also not possible. So I am discarding. What about AB? AB, yeah, S tends to AB, A tends to AB. Okay, again S comma A. Then I am checking for the condition AC. So AC is not possible. So again, it is discarded. So if you check here, it comes S comma A comma C. Okay. So this is the one. What about the first one? So all the four cells are combined, it will come to the first one. Okay. So all the four cells are combined and it will come to the first one. Okay, all the four cells are combined, that is AABB. So AABB is combined, it comes to the first one. Okay, so I am writing different combinations AA and BB. This is one combination. So next combination AABB. Next combination AAB and B. Okay, so now I am checking AA where it comes. So when we map AA, it comes here, C. When we mapped BB, so when we map BB, it comes here, S comma A comma B. Okay. Similarly, A, it tends to A. Okay. So similarly, ABB. So ABB. So when ABB is combined, it is S comma A comma C. Okay, similarly, AAB is combined, these three cells are combined, it comes to A comma C. Okay, when B is given, it is B comma C. Okay, now we multiply all these things. Okay, so CS, CA, CB, similarly AS, AA, AC, similarly AB, AC, CB, and CC. Okay, so now if you check, okay, so if you check this one, okay, so if you check all this one, first one, for time constraint, I am writing the answer. Here only B is to come. Okay, because for CA, only B is, first one CS is not available in the set of rules. CB is also not available. I am writing into only one B is coming. Similarly, for second one, okay, S, A, S, comma, A, and A. Okay, so finally, the answer will come here B. So A, B, A, B, A, C. 1 minute. Yes, A. So somewhere the things is there. So I'm writing here S, comma A, and C. Okay, so we will check it where it comes. Yes, here C only comes. Here C, S, comma A.